Hey, welcome to another fantastical, fun-filled, and fast episode of What If? This week, we're taking you on a pretty wild and speedy journey all through the universe, all about the speed of light. You know, the speed of light is 300,000 kilometers per second. That's 186,000 miles per second. There's nothing faster that we know of. Flick on the lights. You tend to think that light is instant, right? Well, no. Light appears instantly when you flick on the lights at home because of the distance between you and the light. It's only a few feet. Light just traveled a distance of 5 feet at a speed of 300,000 kilometers per second. But think about the sun for a second. The sun is 150 million kilometers away from us. The light from this big hydrogen bonfire, which of course is traveling toward us at the speed of light, actually takes 8 minutes and 20 seconds to reach us. Yeah, you're using 8.5-minute-old light. Ugh, okay. Seriously though, this means that if the sun were to burn through all its hydrogen and helium, which it's not scheduled to do for the next 8 billion years, you wouldn't know it until 8.5 minutes later. Well, you wouldn't know it at all because it would have already turned into a red giant and enveloped the Earth 1 billion years before that. But that's a story for another what if. Am I supposed to say that here or at the end? At any rate, the speed of light is fast. Let's imagine a few things in the universe traveling at that speed. Let's start with the sewing needle. There's a needle approaching Earth at the speed of light. A needle? Well, that's no big deal, right? Well, unfortunately, it's a very big deal. A needle traveling this fast can cause devastating effects on Earth. But why? What kind of destruction could this tiny little needle cause? And in what scenario would this be possible? This is What If, and here's what would happen if a needle hit the Earth at the speed of light. But before we get to that, I want to show you a new video tool I think you guys would be really interested in. It's called InVideo, and they've just released InVideo V3. It allows you to make the kind of videos you've always wanted to create, regardless of your skill level. From my experience, InVideo V3 can bring to life any video idea I have better than the other tools on the market. It's been super fun to mess around with. Just type in the idea for whatever video you want to create.
Now time for the magic. We lower the patty onto a slab of molten lava. Sizzle and pop. The heat is intense and the aroma is mouth-watering.
You can even edit the idea with simple text commands like add my voice. Now, unlike other video tools that take hours to learn and only do one part of the job, InVideo does it all. It's like the creative partner you've always wanted. It lets you focus entirely on your vision and ideas. Now, you can try InVideo for free, but if you want to use their generative capabilities, I'd recommend you go for the generative plan. It'll also save you hundreds, if not thousands of dollars when it comes to editing, animating, and other production costs. This is a bad news, good news kind of story, and I'll tell you why in a bit. But first, let me explain to you exactly what the speed of light is. Well, speed of light is how fast light travels. And in empty space, it will always travel at the same speed. No need to worry about drag or wind resistance. And it can travel around the Earth 7.5 times in a single second. If you were traveling at the speed of light, you'd be going very, very, very fast. No surprise there. But just how fast would you be going? Well, let's think about this in terms of one of my favorite trips, a ride to the moon. The moon is 386,400 kilometers away from Earth, and it takes about 3 days or 69 hours for a spacecraft to go from Earth to the moon. But if you're traveling at the speed of light, this trip takes a mere 1.3 seconds. Zip! Why? Well, because you'd be traveling at 300,000 kilometers per second. The fastest human-made object ever made is the NASA Parker Solar Probe, and that only goes a measly 635,000 kilometers per hour. This is pretty fast, but nowhere near light speed. Light speed is the fastest speed that exists in the known universe. Nothing is able to travel faster than the speed of light, which brings us back to the good news part of this scenario. Creating a needle that could travel at the speed of light would be pretty much impossible. Well, we can look at Einstein's theory of relativity for the answer. According to his theory, as an object's speed gets close to the speed of light, its mass increases. And then, even more mind-boggling, time actually slows down. As the mass of the object increases, it would need more and more energy to speed it up, so it gets harder and harder to push the object to the speed of light. Basically, you'd need to have an infinite amount of energy to make this happen. But let's say an advanced alien civilization has managed to get close to figuring out this physics problem. Instead of 100% of the speed of light, they've engineered a way to make a needle travel at 99.9% of the speed of light. Bam! Take that, Einstein! Okay, but what happens next? Well, you know that a needle is much, much tinier than Earth. If I were to try and tell you how much tinier, it'd be too hard to get all those zeros on the screen, but you get the idea. And because of its enormous speed, it's carrying a huge amount of kinetic energy. Kind of like a bullet. It may be tiny, but it can still do some serious harm because of the speed it's traveling at. So, let's take a look at what happens when this needle hits Earth. What if it landed in the most beautiful spot in New York? Now, I'm not talking about Times Square. I'm talking about Central Park. As the needle hurtled through our atmosphere, there would be an enormous amount of friction generated. Now, we've seen spaceships ignite upon re-entry into Earth's atmosphere because of friction and heat in the air. Well, there's the possibility this needle would begin burning up too and disintegrating due to this enormous friction. But let's assume it keeps going. This fiery little needle would hit the park with a massive explosion. The impact would release a significant amount of energy that would radiate out as heat, light, and a massive shockwave. One estimate calculates that the energy released will be over 100 times the amount of energy from an exploding nuclear bomb. The trees, the grass, the people in the park would be instantly incinerated by the enormous heat of the explosion. The tall buildings surrounding the park and further away in New York City would collapse like falling Jenga towers. Fires would start and everything would start to burn. The explosion itself would create a giant fireball and a shockwave that would pulse out in waves. But the shockwave wouldn't just shake New York City. It would be massive enough to rock nearby states like New Jersey. The ground would shift beneath our feet. The energy released would be equal to the power of an earthquake that's about 7.3 on the Richter scale. We've had one like this before on Earth. In 1906, an earthquake that measured 7.9 on the Richter scale hit San Francisco. It destroyed over 28,000 buildings and killed more than 700 people. Would the impact of the needle on land cause worldwide destruction? Well, there's one scenario in which that might happen, and we'll get to that a little later, but it's also possible that the destruction caused would be limited to the point where the needle strikes and the surrounding areas. So, if you're living on the other side of the globe, you might just be lucky enough to avoid the horrific consequences. Okay, so that's what would happen if this needle hit land, and the results are pretty devastating, but what would happen if this light-speed needle plunged into the ocean? Well, the impact would cause a massive amount of water to rise up into the air. The enormous amount of kinetic energy carried by the needle would explode into the ocean, creating a tidal wave. Would it set off a tsunami? Well, like I said, scientists estimate that this needle would give off as much energy as a nuke. That's over 1 megaton of TNT. This would definitely create a big splash. In 1946, in what was known as the Baker test, a 23 kiloton nuke was detonated underwater. This created a plume of water 2 kilometers high. Waves close to the explosion radiated out at heights of up to 30 meters. So, our needle would probably cause a gigantic plume of water, but it's unlikely to generate a massive tsunami. That's because the needle would create an explosion at a single point in the water. But for a tsunami to happen, massive shifts in water are needed over vast areas, and that's only created by large geological movements like underwater earthquakes. So the good news is you don't have to worry about a tsunami like the one in the Indian Ocean in 2004, which was equivalent to 23,000 Hiroshima bombs. Yeah, Mother Nature is a whole lot more powerful than this needle. Now, this is what could happen to our planet, but what would happen if this needle hit you? What if it made a direct hit on a human body? This is a scenario where the bad news is infinite, since you'd be the first one absorbing this massive amount of kinetic energy. But the good news is you'd die instantly, so quickly that you probably wouldn't feel it, and you wouldn't have to go through all the devastating consequences that follow for anyone that survives. Now, there's a fourth possibility that could have far-reaching consequences for the entire world. What if the needle landed on the site of an active volcano? If this happened, the impact from the needle would create an opening for a lot of pent-up pressure to be released. It would disrupt the magma underground and set off a series of massive volcanic eruptions. Mass volcanic eruptions like this could cause an extinction event on Earth, just like they've done in Earth's past, over and over again. The Toba eruption 74,000 years ago almost wiped out all human beings. Only 2,000 to 20,000 humans survived that eruption and its aftermath. Volcanic ash thrown high into the atmosphere can linger there for 10 years or longer, blocking the sun. This could create a nuclear winter. With the sun's rays blocked, temperatures drop and crops die out. Would there be any way for humans to survive this catastrophe? It's hard to see how humans could survive 10 years or more with our traditional agricultural systems thrown completely out of whack. As plants die, herbivorous animals will die out and carnivores higher in the food chain will lose their prey. So most animals will go extinct as our ecological chain collapses. But there is a slim ray of hope. Scientists have found that some parts of the southern hemisphere, like Australia and New Zealand, might be able to produce food in these very specific conditions. Conditions without much sunlight and low temperatures. But the grim truth is that these areas wouldn't be able to sustain our current global population of 8 billion people. The vast majority of humans would die out, but a small minority might remain. A group of humans who would hopefully emerge hardier and stronger. I don't know about you, but I'm pretty relieved that the possibility of this tiny needle hitting Earth at light speed is close to zero. For once, I'm happy that we're nowhere near being able to produce an infinite amount of energy, and that we don't know of any advanced aliens with these capabilities either. Thank goodness. Speaking of fast-moving needles, I've got an appointment at the blood clinic next Wednesday to give blood. The nurses at my clinic are really good with the needles. Zoop in, zoop out, I don't even feel it. I like giving blood, and I try to do it every 2 months because just one donation can save up to 3 lives. Plus, you get snacks. Raisins, Oreos, juice boxes. You feel like a kindergartner at snack time. Severe lack of marshmallows on the snack table, though, which is fine because they aren't too healthy, and to be honest, they belong at the end of a stick roasting over a campfire. But back to the topic of the day. What if a marshmallow could travel at the speed of light? Look out! There's an object hurtling toward Earth at the speed of light. And no, it's not a comet or an asteroid. Yeah, it's a marshmallow. How could a marshmallow ever go this fast? What would happen to it as it entered the atmosphere? And what kind of damage would it do to our planet? This is What If? And here's what would happen if a marshmallow hit the Earth at the speed of light. Early versions of the marshmallow were first eaten as far back as ancient Egypt. But in the 1950s, these sweets made from sugar, water, and gelatin exploded in popularity. In the United States alone, about 40 million kilograms are sold every year. And over half of all marshmallows sold during the summer months are roasted over a campfire. And then squished between chocolate and graham crackers, some more. Well, I'd like some more of that myself, so let's see what happens when we make the most epic s'more possible. Time to send this fluffy treat hurtling toward Earth at an impossible speed. Warning to all the althiophobes out there, things could get gooey. In a vacuum like outer space, the speed of light is 299,792 kilometers per second. That's so fast that an object traveling at that speed could circle the Earth 7.5 times in 1 second. As far as we know, no object can travel faster than light. That's because the faster an object moves, the more its mass increases. If an object moved at the speed of light, its mass would become infinite. And to move an object with infinite mass would require an infinite amount of energy. And therefore, it's impossible. Until now. If you were an astronaut on the International Space Station, who could blame you for feeling the primal call of a good s'more? It would be a perfect way to pass an idle summertime evening 420 kilometers above the surface of the Earth. But don't worry, you wouldn't need to light a campfire on board the ISS. These space station oven-toasted marshmallows would be completely harmless. Except, wait, one is missing. Uh-oh. If a marshmallow escaped the pressurized environment of the ISS, it would start to expand. That's because marshmallows have small bubbles of air trapped inside them. On Earth, the outward pressure of these air bubbles and the inward pressure of the surrounding air reach a stability that results in a normal-looking marshmallow. But in the vacuum of space, with no surrounding air pressure, the air bubbles inside the marshmallow would expand. That would make it puff up even larger. Now, our misshapen marshmallow would set its sights on Earth. And here's where the impossible would happen. The marshmallow would begin to travel at 99.9% the speed of light, reaching the Earth's surface in less than a millisecond. Okay, how about we roll things back and follow the action in slow motion? As the marshmallow enters our atmosphere, it would begin to slam into the atmospheric particles. At this ridiculous speed, these particles would actually punch into the marshmallow and stay there. So, the marshmallow would actually gain weight as it hurtled toward Earth. This highly energetic scenario would most likely cause the marshmallow to rip apart. This would be a saving grace for us down below because it would create explosions that would dissipate the energy during its trajectory. But if that didn't happen, this once fluffy object would hit the ground with a lot of force. Take the Chelyabinsk meteorite as an example. This meteorite exploded at a height of somewhere between 19 and 24 kilometers over Russia in 2013. With a mass of 11,000 tons, the overhead explosion injured 1,000 people. Our beloved marshmallow, moving at the impossibly fast rate of 99.9% the speed of light, would slam into Earth with a force almost 4 times more powerful than what occurred during the Chelyabinsk event. And it wouldn't hit the ground as a soft, sticky substance either. If it managed to avoid completely burning up in the atmosphere, the high-temperature journey would cause the carbon in the marshmallow to darken and harden, converting it to graphite. The damage that this tasty treat-turned-meteorite could inflict upon Earth would depend on where it landed. If it remained intact and smacked right down into New York City, a 2019 NASA simulation estimated it could result in the death of over 1.3 million people. Okay, maybe NASA didn't actually simulate the impact of a marshmallow meteorite traveling at the speed of light. Their simulation was a much larger 60-meter sugar-free asteroid entering Earth's atmosphere at a comparatively slow 19 kilometers per second. Our marshmallow would likely be less powerful than this asteroid, but it would grow in danger as air atoms would be punched into it during its trajectory. And with more mass comes a greater impact force. Every year, our planet makes one full trip around the sun, and while that means we're already moving at breakneck speeds, we're about to ramp that speed up. Like, way up. Let's turn the Earth into a planet-sized spaceship and crank it up to light speed. Why would this make Earth extremely heavy? What would happen to Earth if it started orbiting so fast? And what would it be like to experience all this from down on the ground? This is What If, and here's what would happen if the Earth orbited the Sun at the speed of light. Okay, nothing travels faster than light, so brace yourself because light moves through space at a blistering 300,000 kilometers per second. That means from the moment a particle of light leaves the sun, hurtling directly toward you on Earth, it takes just 8 minutes before it hits you in the face. Or gently caresses your face. Yeah, it only takes light 8 minutes to travel 150 million kilometers. And light reflecting off the moon only needs 1 second to reach your eyes. Now, when it comes to an object cranking up to the speed of light, things aren't just as simple as picking up the pace. Let's take our planet. As it gets closer to the speed of light, its mass increases until it becomes infinite. And to move an infinitely massive object, you're gonna need an infinite amount of energy. And that's just impossible. Until now. Earth already orbits the Sun at 30 kilometers per second. And while that's not slow at all, compare it to the speed of light and that's not even a drop in the bucket. If you want to be more precise, Earth orbits this big scorching ball at only 0.01% of the speed of light. So we've got a lot of ground to cover here. But don't get ahead of yourself, because even if we just increased Earth's orbital velocity to 42 kilometers per second, we'd be in serious danger. That's because at this speed, Earth would achieve its orbital escape velocity. That means it would be traveling fast enough to escape the Sun's gravitational pull. We'd just be traveling out into space. Another cold, rogue planet with no star system to call home. Of course, we'd cross the solar system before being ejected out of it for good. After about 3 years of moving at this speed, Earth would reach Neptune. At that point, we'd have already passed all the other planets in the outer solar system. If we got really unlucky, Earth might crash into the big ball of gas, Jupiter, along the way. Now, for a moment, that would be a pretty view as we approached, but what a shame it wouldn't last long enough for you to enjoy, because Earth colliding with Jupiter would have some lethal side effects. But we wouldn't let your epic journey end so abruptly. In this scenario, Earth would keep hurtling through the solar system and beyond. We'd keep speeding further and further out of our planetary hometown and into the big unknown. And without the sun's heat, well, Earth would slowly but surely become a cold and lifeless rock. Okay, well, that didn't go as planned at all, so how about we start over? Let's break the laws of physics and keep our planet in the sun's orbit as it reaches light speed. What would that be like? Well, to accelerate the entire planet to such an incredible speed, we'd need a lot of energy. How much? Well, more than you could imagine. Even if you wanted to accelerate yourself to only about 90% of the speed of light, well, you'd need as much energy as the entire world consumes in 5 days. So, where in the universe would we manage to get enough energy to speed the whole planet up? Well, your best bet would be to follow the lead of a very rare but extremely fast kind of star, a hypervelocity star. These are stars that can reach speeds of up to 33% of the speed of light. There may be as few as 1,000 of these kinds of stars in our entire galaxy, all because they need a unique chain of events to unfold first. Hypervelocity stars reach their hyperspeeds by orbiting a black hole that's colliding with another black hole. These two black holes begin a kind of dance with each other, spinning faster and faster until eventually they let go. And that gravitational disruption leads to the stars being ejected across the universe at these insane speeds. Alright, so it's simple. In order for us to reach the speed of light, we just need to swing around a black hole or two. What's the worst that could happen there? Now, experiencing light speed on Earth wouldn't be exactly like what you see in the movies, when the Millennium Falcon or the USS Enterprise engage thrusters. For starters, you wouldn't see any more stars in the night sky. That's because you'd be experiencing what's known as the Doppler effect. In scientific terms, all the light traveling toward Earth would now have a higher frequency, moving from the visible spectrum into the X-ray range. To put it simply, the light from the stars would become invisible to you because the human eye can't see X-rays. And it could mean invisible danger for you. X-rays can cause many health problems and increase your risk of cancer. While today's atmosphere is thick enough to prevent most of this radiation from stars reaching us, traveling at the speed of light might put our atmosphere to the test. Yeah, we could lose our protective air shield, which also means, on this Earth, that you wouldn't be able to breathe. Okay, so everybody dies. Where have I heard that before? Oh, hey, you like this shirt? Good. Well, this is the point in the show where I usually tell you about our merch store. Yeah, we sell these shirts to civilians like yourself so that you can look cool and knowledgeable, and so you can be approached by friends and neighbors who say, "Oh, no way, you like What If too? I love that channel." Anyway, no pressure, but if you want to be cool, shop.underknown.com is the place to get them. And you should get them now because they're moving at the speed of light. Well, not really. The shipping is a few days at the very least. Lots more stuff in the shop too. Hoodies, stickers, mugs, books, posters. Check it out after the show. And hey, stay tuned to this channel because later in this show, we're going to show you what would happen if you could ride your bike at the speed of light. And what would happen if a turkey hit the Earth at the speed of light. Yes, ladies and gentlemen, we answer all the questions you never even thought you needed to know. But right now, let's check out another speed of light video. Only this one is like a Freaky Friday sort of what if. What if the speed of light and the speed of sound were switched? Not at birth, just more like a Lindsay Lohan and Jamie Lee Curtis switched, where one has to act like the adult and Jamie Lee gets to go back to high school. Except not really either of those. Nothing can travel faster than light. But what if we switched the rules a little? Imagine a world where the speed of light was slower, about the speed that sound travels at. In turn, the sound in that hypothetical world would be accelerated until it reached the speed of light. How would the sound sound and the light look? And why would that universe be doomed? This is What If, and here's what would happen if the speed of light and sound switched. Light travels at a constant speed of 300,000 kilometers per second. If you personally were able to travel at that kind of speed, you could zip around the Earth's equator 7.5 times in just 1 second. If sound could travel that fast, well, we'll get to that part in a moment. First, let me explain something. There's one big difference between the speed of light and the speed of sound. Light speed is a universal constant. It's always the same for every observer. For sound, it's different. The speed of sound depends on the density of the medium it travels through. What we usually refer to as the speed of sound is the speed of sound waves passing through dry air at 20 degrees Celsius. That speed is 343 meters per second. And that's almost 1,000,000 times slower than the speed of light. If light traveled that slow, how different would our universe have turned out to be? Since light speed is a universal speed limit, changing it would completely change how the universe works. With the new speed limit of 343 meters per second, everything would be so slow. You'd find that moving at 0.2 kilometers per hour would only be possible with a rocket, or at least a nuclear-powered car. Driving it would be a challenge as you wouldn't be able to see far ahead, but you would experience a cool Doppler effect around you. Things in front of your car would seem blue. In your rearview mirror, everything would look red. In that world, it would take hours to send a message to someone on the other side of the planet. You know what would be even more annoying? Talking to someone who's further than a hand's distance away from you. The delays in visuals would make it look as if you were video calling someone with a bad signal, only in person. We would never be able to make it to space, because to do that, we'd need to escape from the gravitational influence of Earth. That requires the speed greater than the speed of light in our hypothetical world. We'd never reach it to begin with. There would be no moon landing, no solar system exploration, not even the International Space Station. On a more disturbing note, the chemical reactions in your body would slow down. That can't be good. Essential functions like your metabolism depend on those reactions. I can't tell you exactly how this would end, but it sure wouldn't take long. All that, and we haven't even got to the speed of sound yet. For the sake of your survival, let's say that your body adjusted to the slow motion inside it. Now, sound enters the game. It's faster than light now, so you would hear everything before you got to see it. Because sound relies on the environment, in order for this to happen, air would have to turn incredibly dense. We're talking as dense as neutron stars. Not a single living organism would survive under such strong pressure. Not to mention that all this breaks the rules of physics. Nothing can exceed the universal speed limit, and if sound did travel faster, that's not good news for anyone. The universe would collapse upon itself long before we got to experience that cool Doppler effect. You know, when I was a kid, I really did think I might be able to get my bike to fly. wasn't much of a bike. It was a banana seat with those high handlebars and little silver streamers fluttering from the handle grips. But when I came torquing around the block at about 5 miles per hour, baseball cards clacking in my spokes, I really did think I could take some major air off that ramp made of leftover plywood and a cinder block. But instead of major air, I got minor and major cuts and bruises, road rash hands, and a bent front tire. But me and the neighborhood kids got a little closer to our dream when we saw Elliot and E.T. actually taking flight on a bike, skimming the treetops, traversing the full moon in that iconic moment in film. But no one's ever been able to make a bike go at light speed yet. At least, not until now. So, you think you're pretty good on that bike, huh? How fast can you go? Have you done any cool jumps? Pfft, that's cool, I guess, but compared to what I'm going to show you, that stuff is child's play. We took it upon ourselves to give your bike a bit of an upgrade. Better shocks, a nice new bell, and oh, I almost forgot. It can travel at the speed of light. What would you see while you're riding? And how would you look to other people? And this is safe, right? This is What If. And here's what would happen if you rode your bike at the speed of light. They say that traveling at light speed is just like riding a bike. Once you do it, you never forget how. Okay, they don't actually say that, but if you did manage to pedal your way to light speed, it's an experience you won't soon forget. The speed of light is about 300 million meters per second. It's a speed goal that may seem ambitious, but with the new bike we gave you, you should be able to get there. We do recommend wearing a helmet, just in case. As you pick up speed, you're going to notice a few changes. First, you would experience time dilation. Basically, the faster something moves, the slower it moves through time. If you're biking along at the speed of light, time would stand still for you. Pretty cool, right? But then, things start to get trippy. You'd see something called the Doppler effect. This would cause the color of the objects around you to become distorted. As you get closer to objects, they'll turn blue. With light, different colors show us different energies and wavelengths. The higher the energy, the smaller the wavelength. You're seeing approaching objects turn blue because their wavelengths are being compressed. If you look back at the objects you've passed, they'll start to turn red as their wavelengths are stretching out. The further you go, you would start to see wavelengths unseen by the human eye. Ultraviolet or infrared wavelengths would be so compressed that you could actually see thermal radiation. Enjoy the predator vision while you can, though. It's not going to last. Here's the thing. The faster you move, the darker everything behind you will be, as their photons will be less able to reach your eyes. It would be like biking through a big, scary tunnel, and eventually you would only see darkness. Also, now would be a good time to pump the brakes. If you bike for longer than 1 second, you may end up halfway to Mars. It would be an experience, to say the least. But what would it look like to other people? Well, research from the University of Surrey might be able to help us out with this one. Okay, so this is the bike before it starts moving. Clearly, they spared no expense on visual representation. Next, the bike picks up speed. The light scattered from the front wheel of the bicycle will travel a shorter distance than the light scattered from the back wheel. The biker is traveling so fast that when the light reaches the spectator's eyes, the bicycle will be much closer to them than it was when the light was scattered. Essentially, it would almost look like a long photo exposure in that the bike becomes one long movement. The bicycle will be made up of a patchwork of itself at different times. That poor viewer will see both your face and back at the same time. Will it be a once-in-a-lifetime experience? Sure. Will they need therapy? We think so. In other words, it's a mess to look at. In fact, whoever watched this light-speed bike ride is probably going to throw up. Talk about whiplash. So, could you burn some rubber and go as fast as the speed of light? No, sorry. As of now, traveling at light speed is impossible, especially for commercial bicycles. Deep frying a turkey can oftentimes be incredibly dangerous. So, why don't we try a different cooking method? Let's send our turkey up into space and have it come to Earth while moving at the speed of light. Do you think this would be any safer? How fast is the speed of light? Could a turkey moving this fast damage the Earth? And what would happen once it reaches our atmosphere? This is What If, and here's what would happen if a turkey hit the Earth at the speed of light. The speed of light is nearly 300,000 kilometers per second. If an object were going this fast, it could circle the Earth 7.5 times in just a single second. So, what would happen if we made a turkey move this fast and then hurled it toward our planet? Before we go any further, we should let you know that it's impossible for an object to move at the speed of light. That's because the faster an object moves, the more its mass increases and its length contracts. In other words, when our turkey is moving at the speed of light, it would have an infinite mass and a length of 0, which is impossible. But we won't let our fun stop there. Instead, we're going to have our turkey move at 99.99% the speed of light. Ha! Suck on that, Einstein! And now, moving at this speed in space, the turkey is coming for Earth. But before it even hits our planet, we'd notice some of the effects long before it impacts. As the turkey is moving through Earth's atmosphere, it would start to slam into atmospheric particles. Since it's moving at such a high speed, the turkey would begin to get ripped apart. If you wanted to look up in the sky, you'd see bright explosions in our atmosphere. But the volume of the explosions would probably make you instinctively run for cover and hide. This might not sound all that terrible, but it would still cause massive destruction on Earth's surface. The closest modern equivalent to something like this would be the Chelyabinsk meteor in 2013. That meteor exploded at a height of 23.3 kilometers, and when that happened, it resulted in 1,000 people getting injured and huge amounts of property damage. Our turkey, moving at the speed of light, would be equal to 40,000 of those meteors hitting Earth. And these explosions wouldn't happen all at once, but sporadically as it moves through the atmosphere. As they happened, their shock waves would cause buildings and windows to be completely destroyed. And if this were to happen, it would be the Earth's best-case scenario. That's because this turkey hasn't even hit the planet yet. But if it did come right for us, then the results would be even worse. Due to all the energy behind it, if the turkey hit New York City at 99.99% of the speed of light, it would be like dropping 400 nuclear bombs. This would completely destroy the city, not to mention parts of the planet itself. The impact from this massive explosion could destroy the Earth's crust, causing magma to spew up and fill the streets. Massive fires would start and millions of people would die. But Ground Zero wouldn't be the only place heavily affected. An impact to Earth like this could cause earthquakes and fires all across North America. An entire half of the world would be completely destroyed just from a harmless turkey. So, the speed of light can be pretty dangerous. As God is my witness, I thought turkeys could fly. Well, that's it for today's tour. A hot and hurried hypersonic hike, hunting the hustle and haste of the speed of light. Hope you enjoyed and pump your brakes. We'll be back soon with another What If? Hey, welcome to another fantastical, fun-filled, and fast episode of What If? This week, we're taking you on a pretty wild and speedy journey all through the universe, all about the speed of light.